Happy day, everyone. This is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Please do not forget to like, share, subscribe, and click on the notification button to have more of my video. Today, we are taking calculus in mathematics, and under calculus, we want to prove what is cos x using the first principle. So look at the title: proof of cos x from the first principle. Now, before we do that, we should have a background of compound angles. We should have a background of compound angles for us to be able to do this work. Then we should also have a background of what is called limits of function, limits of functions. So a particular limit of function we are going to use is that of limit of sine x over x as x tends to 0. So in this case now, our x is measured in what is called radians and not in degree, and that limit is actually 1. So we need this background to be able to understand how to derive cos x from the first principle. So we start. Let our cos x, let's say y is equal to cos x. That's where we are starting from. So in this y's now, any little increment in x will lead to the increment in y. So we can say y plus increment in y is equal to cos x plus increment in x. Now, this one that we have now, what we actually wanted to prove is to find the limit of increment in y with respect to increment in x, as increment in x tends to 0, which we take it to be dy dx. That's where we are going. Please take note of that. So what I'm going to do now, since I'm working towards delta y over delta x, I will go here and make delta y my subject of formula. So I have cos x plus delta x is minus y. I've taken this y to the other side, and since my y is cos x, I will substitute it here. So that means delta y will now be cos x plus delta x minus cos x. This expression that I have here is similar to getting an expression for the compound angle for cos. We recall that cos x, cos a plus b, or cos a plus b is given as sine a, cos a, cos b minus sine a, sine b. So we should take note of this expression, and also cos a take away b is equal to cos a cos b plus sine a sine b. This is compound angle. The idea of this compound angle pictorially, like for instance, if I have a right angle triangle, and this particular angle is angle 90 degrees, then I have another angle which is a right angle triangle. If this angle here is a and this angle here is b, then the total angle for the whole triangle will be angle a plus a b. So what we have here is a compound angle. That's the idea of what this one is referring to, and this is the expression for them. Now, if you look at the expression I have here, I'm subtracting cos x. I'm subtracting cos x from cos x plus delta x. That means if this one represents cos x plus delta x, then this cos a minus b will represent cos x. So that means I'm going to subtract this from here based on what I have here, this subtraction form. So if you subtract, we have cos a plus b. When we subtract, this one will cancel out. Then we have minus 2 sine a sine b. So in a nutshell, since I'm subtracting, I'm going to write this one out. It's going to be cos a plus b minus, yes, when we subtract, then we have this expression. Since I said a plus b is the same thing as x plus delta x, and my x is the same thing as a minus b, I can write them out. I have x plus delta x is equal to this a plus b. Call it equation 1. Then x is related to a minus b. X is equal to a minus b. Call it equation 2. So we want to express this a and this b in terms of x and delta x. So what I'm going to do, to cancel this b, I can add these two equations so that this b will cancel. Then I have 2a on this side of the equation. Then for here, I'm going to have 2x plus delta x on this side. Therefore, getting my a that I'm looking for, you make a subject of a formula here. So it's going to be 2x plus delta x divided by a. I've gotten an expression for this, divided by 2, sorry. I've gotten an expression for this a. So to get this b, in this expression, to be able to get b, what I'm going to do is to subtract this second equation from the first one. So if I subtract here, this one become minus times plus, this one become plus, and then this one become minus x. If I add it to this place, I'm going to be left with a delta x on that side. Here, when I subtract, this one become minus a, because this minus will affect it. This one become minus a. If I add to this place, my a take away minus a, a take away a will be 0. Then this one become plus b. So b plus b will give me 2b. So in a nutshell, this b that is here now, I want to have an expression for it, and that b is actually delta x divided by 2. So I've gotten my expression for what I have here. So what I have here now is the one I've expressed in this format. Then I ended up here. So I'll just say that my delta y now will now be minus 2 sine a sine b. Since my a has been taken to be this, I will substitute it here. So delta y will now be minus 2 sine. Then for the a, I have 2x plus delta x divided by 2. Then I will say sine b. My b is delta x divided by 2. Delta x divided by 2. Now, I want to express this this particular expression here in terms of this limit. This limit of the limit of this particular limit I have here. I want to have an expression in terms of this limit, so that when my x tends to 0, then my limit of this function will be 1. So what I'm going to do there is this. I'm going to take this 2 that is here to this place. So let me write this one out as sine 2x plus delta x divided by 2. Then this 2 will come here. Then this minus, I still leave it, but I carry this 2 to this side. So it's going to be 2 sine delta x divided by 2. Now, since I'm looking for delta y divided by delta x, so that I can be able to find the limit to get the y dx, what I'm going to do, I'm going to divide both sides of this equation by delta x. So I'm going to now have delta y divided by delta x is equal to minus sine 2x plus delta x divided by 2 times 2 all over delta x, then times sine delta x all over 2. Now, this expression can equally be rewritten in this format, and that format is this. Since I'm multiplying this expression with this expression, I can put it in the form of division. Let me write this. I can write it as sine delta x divided over 2. Then instead of this multiplication, I can write division. When I'm writing the division, this one will go up, this one will come down. I'm having delta x divided by 2. Then I can now have minus sine 2x plus delta x divided by 2, then sine delta x over 2. This division sign can be written like this: delta x divided by 2. So this expression that I have here, is similar to this expression that I have here. Now, let me now take the limit of both sides of the equation. I can now write limit of delta y with respect to delta x as delta x tends to 0 is taken as what is called the y dx. As delta x tends to 0, this one becomes 0. So I'm going to have minus sine 2x divided by 2, and also taking limit of this expression sine delta x over 2 divided by delta x all over 2 as delta x tends to 0. Now this particular limit that I have here, since the same parameter that I have here is the one down there, and this delta x is tends to 0, this expression is similar to what I have here as a standard limit. So the limit here become 1. So therefore my dy dx that I'm looking for eventually become minus sine, you can see 2 divided by 2 become 1, leaving x here, and this one, this expression I have here, the limit is 1. So finally dy dx is equal to minus sine x. This is the proof. So anytime you are having a function, let's say f of x, which is a y, which is given as a cos x, we say dy dx is equal to minus sine x. You can use similar procedure to get expression for dy dx of sine x if given. So I want to appreciate the fact that you take your time to listen to the procedure. It's very simple. So once again, this is Orekoya Olusegun Physics Mathematics Fundamentals on YouTube. Do not forget to like, share, subscribe, and click on the notification button to have all of my video. The essence of sharing is for me to be able to reach the targeted audience. I mean, the video may not be relevant to you, but let me share it until it gets to people that will need it. I'm talking about final year students in secondary school, first year students in the higher institution, even all students at every level in the higher institution too. They need this differentiation knowledge. Thank you so much. Have a nice day. Bye.